What's up, my prodigious plumbing adepts? I am your humble host, Hollywood, and today we are replacing a shower valve. I wanted to show this job with as little editing as possible to highlight all the problems that can occur. If you like this type of content, subscribe for more to come. Leave a comment with any questions or advice, and I'll either answer it or ignore it like a well-adjusted adult. And we're going to start off the video by just removing the handle and the trim plate of the old valve. This is looks like a Price Pfister Avante style, where it's a push-pull handle and then you adjust the temperature by rotating the handle after you pull it open to adjust the volume. And all these valves could be different on the wall. This is just one example of one model. Remove the plate screws, but there's a chance there won't be any on certain models. If the screws aren't readily visible, then the plate is most likely held on by the handle. Unscrewing the handle will free the plate. Remove the handle, remove the trim plate screws, and usually the plate will just slide off the body and expose the body behind the wall. In this case, once we pull the plate off, look at that nastiness. That is chewed up. So they mounted the old valve directly to this one-piece tub before they slid the tub into place. And the trim plate for this valve was concave in shape, and the plumber didn't realize this hole was too small until much later in the job. Then they simply widened the hole with some pliers until the plate fit. And here we have our Moen box. This is the Moen Chateau. I believe the model is the L2369EP. You have the valve body with the cartridge in the body. And here we have the template. The template, I like this model because it's made for remodel plates. It has a giant plate to cover up old valves, just like this one. A three handle or a single handle, doesn't matter. And it has that cutout for the three handle or the single handle. And you just draw around the template, and you can cut up to that template line. And that's what we're doing here. We're taking a pencil and marking off the template line, and as long as you cut inside that line, the plate will cover the hole. And you can perform this task with a tile enclosure as well, but you will need an angle grinder and a vacuum for that mess of cutting the wall open for access. So we take our oscillating tool, and this is a fiberglass tub, so it's very easy to cut through, thankfully, and it doesn't make a huge mess. You have some fiberglass dust that settles pretty fast, especially if you're using an oscillating tool like this. Probably my favorite way of cutting a fiberglass tub is to use an oscillating tool. It just keeps the mess down. And this is the Flex oscillating tool. If anybody's interested, this is the best oscillating tool that I've ever used. Hands down, not even close. I used to use a Rockwell when I used corded tools. I had a Milwaukee, a 12 volt and an 18 volt, both of which were disappointing. When I bought this Flex one, I was blown away. But it's got some drawbacks too. Namely, the blades use the Starlock mounting pattern. And while I love the ease of swapping blades with Starlock, hardly anyone sells the Starlock accessories. But the design of the Flex multi-tool is immaculate. Alright, we have the old valve exposed now. It's hard to see. We have the hot and cold copper lines coming in to the sides and the pipes going to feed the tub spout and the shower head. You know, it dawns on me that we really should go over the valve body a bit before continuing. While this video is aimed at intermediate and advanced level plumbing experience, I should go over the parts for any beginners watching. I have 3 different valve bodies here from my boneyard as examples. First, we have the Kohler, and you can see the brass body that houses the valve and controls the water temperature and volume. This is the piece that sits inside the wall behind every shower. Every valve will be marked with the hot and cold inlets, but this design is unique. If we pull out the cartridge, you can see that the tub and shower connections are reversible. This model allows the water to travel through the cartridge itself to feed the shower if someone pulls the diverter on the tub spout. You will still need to install the cartridge with the cold on the right and the hot on the left, because the valve will open with the cold supply first. If you get that backwards, then you will have hot water instead of cold as soon as you turn the handle. Also, a lot of modern valves will have half-inch male thread connections that can also accept half-inch copper pipe for sweating connections. Inserting the copper pipe directly into the valve body is a handy practice, and I appreciate the versatile design. Next, I have a Price Pfister valve body without the cartridge to show, but you can see the similarities to Kohler. This body is clearly labeled with the tub and shower ports needing to be installed correctly in the wall. So inspect your brass body thoroughly and make sure it's oriented in the correct position when you solder it in place. You can see how it works with the water being fed downward toward the tub spout first, and then there's a tube built into the body to direct the water to the shower when someone pulls the diverter. So this model is less forgiving than the Kohler, but this style is far more common, as we can see with the final example of Moen. This is the same brand as the one I'm installing on this job, but it's lacking the isolation shutoff on the hot and cold supplies. You can see the cartridge is marked H and C to indicate how it should be installed, and the body itself is marked with a simple up label to tell you how it should be oriented in the wall. I'm missing the trim sleeve that goes over the body for this unit, but the tab that sticks out on top of the body is designed for the sleeve to sit one way, so it's harder to mess up. You can also see the tube built into the valve body that directs the water to the shower head. If you have a shower head only and you don't need the tub, you can simply cap the bottom, and the shower will be the only thing that works. All three of these examples have the 1/2-inch male thread and solder connections, and that's very common in the industry, but it's not a guarantee. I finally want to go over the plastic trim guard that clips onto this valve. This guard serves a few purposes, but the primary function is to give you a depth in the wall to set the valve to. This little distance between my fingers tells you where the finished wall will sit, and there is about 3/4 of an inch that you can play with. But you want to aim for the tile or the fiberglass finished wall to sit somewhere in that plane. All brands are different and have their own quirks and installation needs, so you need to be aware of what you're potentially working with. Thank you for this TED Talk, and now back to the video. We pulled the trim cover off the new valve, and that cover is telling you where to set the depth of the valve in the wall. Kind of unnecessary, it's pretty much set for us. We can adjust a little bit when we set it new. And this particular Moen valve came with a couple of stops, so we have hot and cold shutoffs built into the valve, which is nice for maintenance. So if you had to replace the cartridge, you could just turn off those stops once you pull the plate off and turn the water off to the valve, isolate it from the rest of the system, and then pull your cartridge and replace your cartridge. Very handy and not necessary for most homes. But we have to remove those cartridges before we can install the valve. I'm rotating the stem of this Moen cartridge to close it, because Moen has the quirk of shipping all their PosiTemp cartridges in the open position, and when you turn the water back on, it can be a surprise if you don't know. And we just remove the clips, and then pull the stems right out. Also, please ensure the water is off to the home before you cut any lines or the old valve. And now it's just a brass body that we can heat up. We can solder in place and no cartridges will be damaged. Again, in this tight space, I like to use my oscillating tool to cut the copper. So I can just take a carbide tipped blade and just cut right through the copper with the oscillating tool. And it does leave a bit of a rough edge to the end, but you just have to clean that up really well. And it'll be fine. I like to use it maybe better than a Sawzall in some cases. In this case, I didn't want to drag my Sawzall up the stairs along with everything else, so I just elected to use the oscillating tool. Apologies for the poor camera positioning, but I'm wearing a GoPro chest mount and it's hard to control and see what's going on the camera and what I'm doing as well, so apologies for that. I'll get better, I promise. My jacket getting in the way. And we have the old valve removed. And now with all the pipes exposed, the next step is to set the valve and see where it needs to be. So we're going to clean up all these pipes. We have 4 pipes. We have one going to the shower head, one going to the tub spout, and the 2 hot and cold coming into the sides. We have to clean up all of these pipes and get them ready for installation. And a few extra moments of cleaning these things can save a ton of time. So you take a few extra 20 seconds, 30 seconds to clean a pipe, especially if it's old and been in the wall for a while. Clean that up. I'm simply using my channel lock pliers to scrape the outside of the pipes and remove any loose bits to make it easier to sand and clean. We're actually going to take our torch here. It's a nasty looking flux brush. I'll just grab another one. Take our mini copper tubing cutters and get that in the wall where we can't reach. There's solder boogers attached to this pipe from the old installation. I'm going to try to cut off to a usable space below that. Apply some flux. And we're just going to actually use the torch, in this case, to melt the old solder away and try to salvage that pipe. In tight spaces like this, you have to take as much advantage as you can of the pipe that you have and salvage what you can. We can't afford to cut the pipe below our hole and make it extremely difficult to work on, so we have to work in this hole that we have. So we keep our flame nice and low so we don't burn anything in the wall. Keep our flame concentrated on one spot. And I'm going to get some flack from some plumbers, I'm sure, about having a low flame on that torch. But I'd much rather have a low flame on the torch and ruin the tip prematurely than start a fire in a wall, which is why I actually prefer this torch as well. This torch is fully adjustable. The head is not preset. You can adjust the flame. And, just like me, it has a thin tip to fit inside tight spaces. It's a very versatile torch. This isn't a soldering tutorial, but if you'd like me to make one, leave a comment and let me know. And we cleaned up that copper pipe pretty easily, and before even the damage was done to the torch tip. So we heat up the pipe and heat up the solder drips that are still on the pipe, and when they start to melt, we'll take a rag and wipe them down and get a nice smooth surface. And we'll use some flux to clean it up afterwards too, while it's still hot. Again, I'm showing all this so you guys understand how these jobs work and how they go, what to expect. Even if it does seem a tad boring, there is a lot to learn by observing the process. Alright, after the pipe is cooled, we'll take our reamer and clean out all the inside areas of all 4 pipes. And sandpaper. Sanding down the pipes that have been freshly cleaned from their solder drips is important. And try to get bright and shiny copper showing is the best way for a good seal on your new solder joint. Just take a little extra time and clean these pipes up super well. This is a very important part of the process. I've had plenty of apprentices come through my doors that are impatient, and they don't take enough time to properly clean the pipes when working on old systems, and then they have leaks, and they can't understand why their solder joints are leaking. That's why. It's most likely because it's not properly cleaned. I'll take a mirror and I'll inspect the back ends because I can't see in the wall very easily, and just make sure that the pipes are cleaned all the way around and ready for solder. And I'm showing this whole process just to highlight how important this step actually is and what goes into this whole job. If you want to understand what we do and why we do it, this right here is a good example of the process. With the pipes cleaned, I'll set the valve body on the tub spout riser first, because it's the easiest starting point with gravity holding it on the pipe way better than the shower riser above. And building the hot and cold supplies with 90s is a mostly painless process once the valve body is set in the center position. But use your best judgment. If you want to start from the shower head stub, that's fine too. We'll set the valve on the tub spout and see if we have to raise it up a little bit. Once we set the valve in the wall, we can see if it's centered in the hole we just made. If we have to raise it up a couple inches, we can do that with a little piece of pipe and a coupling. And we clean those up as well. Take a little fitting brush and blow out the inside of that coupling that's been sitting in my dirty box for months on end. My dirty toolbox, that is.
Oh, don't look at my bum. I caught you sneaking a peek, cheeky monkeys, all of you.
Right. And I like to mark my pipe cuts with my thumbnail. I'll hold a tape measure on the pipe and I'll put my thumb right on the line where it needs to be cut, and then I'll hold my thumb in that position until I get my cutters in position, and then I'll remove my hand and cut the pipe. It's a very fast way of doing it in the field. It's not as precise as a pencil mark, but it's very close, and it's close enough where I don't care, and it saves me the time. And ream that pipe as well. Ream all your pipes. It's very important to do so. Buy a little pipe reamer for $10 or $12, and they come with 2 blades. There's no excuse not to ream your pipes. And now we have a little stubby piece to raise up the valve off of the tub spout riser. And we'll flux up the inside pipe there, put our coupling on, and put the riser piece up higher. And now we can set the valve and make sure that it's in the right position. Don't assume anything. But once I set this valve in the center of the hole off of the tub spout riser, that will tell me all the other measurements I need to take to install the rest of the pipes. This will determine everything else, so this first step is critical. Clean our valve with a fitting brush, always do that. $1 for a fitting brush is a small price to pay for a clean joint. I wish I had a flashlight set up in that wall, but the hole is so small and the space is very limited, so I really couldn't set up a flashlight very easily. I need to get some body-mounted flashlights for these things so you guys can see these things better. Again, my apologies for the poor camera placement. I'm doing the best I can. I had actually had the GoPro on a chest mount, and I had moved it up to a head mount because my jacket kept getting in the way of the shot. So I had cut the extension piece for the riser just a little high, just a little long, and that piece is so stubby that it's hard to cut. So I didn't want to have to cut more pipe off of that stubby piece because that's very difficult to do on short pieces because you have no meat to grab and rotate your pipe with. So I ended up just cutting up the riser another 1/4 to a 1/2 inch off the riser. I forget what the measurements was. But the riser was a much longer piece to work with, and I wouldn't have to sacrifice the piece I had already cut for the extension. So now the extension should be the right distance here. And if we're centered up in the wall here, or in the hole I should say, now we can start to work and build this valve off of the rest of them. But this little stud, there's a stud right next to this valve that we have to contend with. This stud is a problem. This valve in particular has those shutoffs built into it, so the hot and cold supplies stub further off than a standard valve do, so they take up more space in the wall. And that stud wasn't a problem for the previous installation, but it's a problem for us. So we're trimming that stud just a little bit to give us more space to work. I don't want to start a fire and have a solder joint right on top of a stud. In this case, the stud is directly in the way. I'd have to drill the stud out or cut the stud out of the way. So I'm just trimming the stud up a little bit to get more room to work and to decrease the fire risk. Fire risk is always present on a job like this.
What do we do?
Here, use this!
So now with that cut out of the way and the valve in place, we can see where our hot and cold supplies are. And this one's going to be too long, so we're going to have to cut this guy down and build it out with a few 90s to get it back over where it needs to be. But the riser I had cut previously was too high. And this is not something you can really see in the future for. You just have to kind of cut it and leave a little extra meat so you can cut it down like this. You don't want to cut it too short and have nothing to work with. So using a pair of thumb cutters in the wall is probably best for this, but it's also tedious and time consuming. Again, reaming our pipes and cleaning up the new cut that we just made. Setting the valve, and we installed a street 90 on the one side for the hot side, the left side, and the the street 90 in place, we can take eyeball measurements with our pipe and start putting it together. So we set another 90 on the riser, the hot riser coming up out of the wall. Put that in position and get another measurement for our piece going up to the valve. Alright, in the pipe, applying the flux on all the joints. Flux is a mild acid that will clean the pipe and make sure all the impurities are gone and help the solder run into the joint. The solder will follow the flux, so if you have too much flux and it rolls down the pipe, the solder might roll down the pipe to follow the flux with the heat as well. So you don't want to use too much flux, but you don't want to use too little either. Better to use too much than too little. Okay, we try to roll our 90s into position, and they are giving me hell. Watch me struggle with this. Yep.
Round one. Fight.
I have to get a pair of channel locks to try to push it into position.
Shoryuken. Huh.
And cursing on the job site is a standard function, so if you hear your contractor cursing in a bathroom where they're working, that's just them getting the job done. Don't worry about that.
You fucking. Shoryuken. I'm so sick of this shit.
I'll try to keep the cursing to a minimum, and I'll try to keep it low on the volume, decibel level, but sometimes
Oh my god.
these things are a pain in the ass, and a good F-bomb can really make sure that your pipe gets in the right position. So if you hear the F-bomb go off, that's just your job getting done. Don't worry about it. It's just giving me a hell to try to get that pipe together in that tight space.
There we go. You win.
And in this case, I didn't have enough room for a repair coupling. A repair coupling is simply a coupling that has no stop in the middle. So you can slide it all the way over the pipe and then slide it back over. So you can set your pipes together and then slide your repair coupling over the other edge. So this isn't a huge problem. I will use a repair coupling on the top end because I have that space to work for the shower head riser, but the hot side installation, I didn't have one. And planning ahead a little bit to set your next pipe is important as well. So determine which pipe would be the easiest to install last. In this case, I thought the cold side would be the easiest to install last because we have 190 and some flex in the pipe that I could manipulate to my advantage. So I set the tub spout, I set the hot side, and then I'll set the shower head riser, and we cut our section of pipe to meet the other pipe, and then we'll use a repair coupling above to get those connected. Cleaning and reaming, very important. Once again, always clean and ream your pipes. There are very rare circumstances where reaming a pipe isn't that necessary. I would say if you're installing angle stops and you're using a copper tubing cutter to cut your pipe, you don't have to ream that necessarily. I still do just out of practice, but that's one of the only joints that you don't have to ream. Alright, we set our repair coupling, apply some flux, and then roll that coupling down to make the joints meet. If you like this long-form style of job breakdown, be sure to like and subscribe for more. Comment with what kind of plumbing project you might like to see next, and I'll see what I can do. I've come to the realization that it's just not going to work out. We have to cut that piece shorter. So I'll have to take it back apart.
You lose.
Oh well. Cut that piece just a little shorter and put it back together. This is what happens when you don't use a tape measure. It's called hubris, boys and girls. the old piece, install the new one. And look at that, it goes right together. Channel lock's not even needed.
Perfect.
Alright, and now that the cover's together, we're hooking up the last piece, the cold side connection. Clean your fittings. A few extra seconds of prep time will save you leaks in the wall later. That coupling that coupling has a sticker on it for the barcode. I hate that, but I don't know where else they're supposed to put it. But getting that thing off there is a pain in the ass. And then it just burns. And I probably should remove it. This is a mistake I made right here, is leaving that barcode sticker on there, because when you heat that coupling up, there's a possibility it'll burn off and then fall into the wall and start a fire. So I was a little bit impatient. And if there's ever a barcode or any other kind of impurities on the part of the pipe that's being soldered, you need to remove it. There's no options. It's got to go. Alright, now that the valve is put together, we will solder her up. This is my preferred torch, just because we can keep that flame nice and low, especially in this in-wall segment where it's so critical to be able to control your flame. So we have that little knob on top of the torch that controls the volume of the flame. Keep that nice and low. I don't care that a low flame is actually bad for your torch. You're supposed to have it on high because a low flame puts increased heat at the tip of your torch, and that will decrease the lifespan. I don't care about that. I'll buy a new torch, but I don't want to start a fire. Yeah, you can see the torch, the tip is getting a glowing red state, so you have to be aware of that when you're doing this. So when I pull my torch out of the wall, flame awareness is key, so you have to make sure it's pointing in a safe direction, and you're not melting anything on the walls, not melting your tub enclosure, not starting a fire somewhere else. Now look at that. Trimming the stud a little bit allows a better angle to point the flame in a safer direction. And that red tip also will be, when you turn the torch off, you have to make sure it's not going to be touching any surfaces, no floors. It should be out in the open, in the air, to cool down for a few seconds. I like to hold my solder with a bend of solder so I can get around the backside edges really easily. Half-inch heats up very fast, and this is only half-inch pipe, so we're able to heat the pipe up very quickly, even with a low flame. You'll feel the solder suck into the fitting, but it will take some practice to know the proper amount of solder to use. This is the reason I showed all the boring bits of sanding and prep work, because it makes this part so much easier and you can feel confident in your solder joints. I turn the flame up just a little bit more on the valve to help heat the valve up just a little faster. We're going to do the coupling on the bottom first. Typically, when you're doing solder, you want to start at the bottom joints because the heat will rise, and the heat will usually start to heat up the upper pipe as well if you start at the bottom. But if you start at the upper pipes, you're losing a lot of that heat. So use the heat to your advantage and start at the lower joints if you can. But it's not that big of a deal. Oh, you can see that that sticker. The sticker's starting to heat up. Yeah, see? See, that sticker is starting to blow off. And that could potentially start a fire. It's not that big of a deal, but it's slightly concerning. But I have my spray bottle handy, You always keep a fire extinguisher and a spray bottle handy. Spray bottle with water is great for cooling your joints afterwards. It's also a fire extinguisher in its own right if something starts to go wrong. Especially with the water turned off, make sure that you have a spray bottle or something close by. Heating the top of the valve, we're almost done. We just have a few more joints to do. I think 2 more joints, 3 more joints then technically with the coupling above. I try to apply the solder to the back of the joint first, but that's hard to do as well sometimes. So when the solder starts to flow, it will follow the whole joint. So if it starts to flow in the back of the joint, it's a lot easier to know that you've got the back done. Alright, when you put the torch down, make sure the torch is pointed away from any sensitive surfaces. I like to do a dry wipe on my joints first, and I can cool them off later if I need to, but there's some discoloration that happens when you use a spray bottle immediately after heating up a joint. It rapidly cools the pipe and causes a discoloration on the pipe. I don't like that too much, so I'll try to let it cool down naturally as much as possible. Gotta be careful though, it's very hot in there. Now that the valve is done and secure, I can pull off the tub spout. I like to leave the tub spout on to get the valve in place to make sure the pipe is as stable as possible, but this case is a little bit weird. I wasn't expecting to see that galvanized nipple coming out of the wall there. They put plumber's putty around that edge too, which is not wrong, but it's kind of gross. A little caulking is much better than plumber's putty, and the galvanized nipple is prone to electrolysis. On a system like this that is fully made of copper and brass, this galvanized pipe is going to fail. Not to mention, it can be an absolute nightmare to remove after a number of years. So we wrenched that. See? Wrenching on that tub spout will put a lot of stress on the pipe too. Look at that old, gross galvanized nipple coming out there. So they have copper and brass in the wall, and that galvanized nipple, you never ever ever put a galvanized nipple for a tub spout. And when brass nipples are only a few dollars more, this is inexcusable. And this is an old fiberglass 90 that actually attaches to the tub body itself. There's 2 nuts that sandwich against the wall of the tub that secure it to the tub itself, which is an old builder's way of doing it. Which is how the builder prefabs these tubs with the valve already in place, so the rough-in crew can work faster. And all that gross galvanized crap that was in the pipe from the corrosion on that galvanized nipple, it's got to pull it out of there. We'll take off the shower head as well and see what's going on there. Do yourself a favor and use an adjustable wrench or something without any teeth. I have seen countless new construction jobs with chew marks in the finished product, and that never ceases to piss me off. Pull off your hoses and then remove the cradle. They're going to save this shower head, they're going to reuse it. They don't want the shower head that comes with the valve kit. So we'll put this aside. Drop my wrench like an idiot. But we're going to replace the shower arm coming out of the wall. And this is a handy trick that a lot of plumbers will use. You actually just stick the handles of your channel locks right in the mouth of the nipple and use that as a wrench so you don't scratch the finish. And that's the same thing, the shower arm 90 up top that attaches to the fiberglass itself. We're going to tighten that nut up to make sure it's a little more secure. But there's threads built into the back, half-inch pipe threads built into the back on the tub spout and the shower head that we have to utilize. So, right here. I should have seen it. Should have seen it coming right there, but I didn't. Maybe some of you eagle-eyed veterans already spotted my mistake. I'm looking for a male thread adapter right now. We're going to spend a lot of time adjusting this tub spout stub for a copper connection, but we can't use that. A lot of you will see that already, what the problem is. But normally, with a copper slip connection on the tub spout, we're going to need copper pipe coming out of the wall. So here we have a threaded connection inside the wall and a copper connection outside. So we're going to solder on the male thread adapter and stub out a piece of copper pipe to attach the tub spout to. Put a rag down to protect the tub from solder drips. And normally this technique will work just fine, but it only works, well, I won't spoil the ending. Some Teflon tape and pipe dope on that threaded joint. And now I'll grip the end of the copper with a pair of channel locks and twist it in there. And I'll just cut that bent end off for the tub spout, because I have no way of putting a backup wrench on that. But now I'm realizing that it's not going to work.
Oh no. Oh no. Shit. I fucked up.
The copper slip hardware inside the tub spout is going to stop against the brass threads protruding from the tub spout fitting, and it won't be flush with the tub wall if I put it on there. That tub spout's not going to work, and I wasted a bunch of time modifying the system for that tub spout that's not going to work in the first place. That's the real lesson here, is just admitting your errors so you can fix them faster. But boy, this is hard to watch myself make this big of a blunder. But now that I need to make a trip to the store for a new spout and brass nipple, I need to get the water turned back on so the customer can use it in the home without waiting further. Pushing the Moen cartridge into place, putting the retention clip in. And then the stops. Hot and cold, it doesn't matter. You could put either one in either hole. They're the same part. It's just a rubber seal that twists to the side like a regular valve does. And the positioning of the slot for the screw is the open position. If that slot is perpendicular to the pipe, it's closed. If it's horizontal or parallel with the pipe, then it's open. And retention clips on those to hold those in place. And that's ready to go. Let's turn the water back on and get them pressurized so they have water to the rest of the house while we go get the parts from the store. And we're back. And now I have the right parts, a new tub spout, and a brass nipple. So we're going to use brass this time and not galvanized. Brass is a neutral metal that won't corrode. There's no electrolysis happening with brass. So we got the right length. We had to measure that to make sure it's the right length. And this measurement was either too long or too short with the pre-built nipples that you buy at the store. So we're going to go slightly on the short side so there's no gap between the tub spout and the wall of the tub. Apply Teflon to both sides. I'm using a lot of Teflon here just because the nipple's slightly short, so it's not going to be able to screw together as tightly as it should. But this is just a tub spout anyway, so it's not going to hold that much pressure. So we're going to start the nipple on that side with some pipe dope and liberal amounts of Teflon. and then we're going to pipe dope in liberal amounts of Teflon on the other side, and then screw the tub spout together. And now the hollow tub spout design will cover those brass threads protruding from the tub wall. We'll get a few turns out of it. One more, all the way around. And we're going to test right now. We're going to turn the water on, make sure there's no leaks, slip our plate on. This nice big plate looks great. It's a big plate that is made for this purpose, so it doesn't look like a remodel plate. It looks like just a big plate. It's kind of why I like it. Often remodel plates will be separate, and the other plate will go against the remodel plate, and you'll have two plates on the wall, two trim plates, to cover up the hole that you had to make, which doesn't look as nice as this, I think. I'll use my drill. I won't tighten it down, but I'll put the screws close to tight with the drill, and then I'll tighten it by hand. So it saves me a little bit of time and my wrist screwing that thing all the way down. And there's a seal built into the trim plate as well, so we don't need to caulk that plate unless it was tile and it had an uneven surface. But with the even surface, I'm fine with it. Here's the handle. And that's the temperature adjustment right there, that white piece going into the stem. There's two little pieces that come together, and you can adjust that by rotating it. And it will stop the handle from rotating all the way to the hot side, so you can adjust the temperature so people don't scald themselves. It's an anti-scalding measure, but I'll let people be the judge if it's too hot or too cold for them. Usually, unless they have young kids or elderly and they're worried about it, I'll usually just adjust it to the max so people can get as hot as they want. Alright, the handle adapter goes onto the stem, and the handle goes right on with the set screw underneath. Apologies for the poor camera placement. I couldn't tell where my GoPro was when I was doing this. I'm sorry. I'm putting the handle on right now. Put a little Teflon on the shower head. Try to avoid pipe dope. You can put pipe dope on the shower head, but sometimes it will clog up the shower flow limiter that's built into the shower head. Most of the time we'll not use pipe dope unless I can't stop a leak. And then I'll use a little bit of pipe dope on the back threads to help seal it up. And this is an old existing model too, so these hoses often will leak on you after you put it back together. And I'm going to use a little bit of caulking here just to hold the plate against the wall, the escutcheon. So I'll put a little dot, two little dots of caulking behind the escutcheon to hold it against the wall, and once that dries, it'll hold it in place. And we'll caulk the tub spout. Finally, the last step of cleaning your work area. I'll wipe out all the dirt and debris in the tub and wash it down during the testing phase. Don't just wash everything down the drain, as you might clog it up. That is not job security, no matter how much you tell yourself otherwise. And a clean presentation at the end is a much better impression for the customer. So make sure you clean every spot you were in. Testing and cleaning a little bit. We don't want the caulking we just installed to wash away, so I'll try to avoid putting water on the tub spout as well. Turn off the water, put her back, and you're done. Another job well done. If you enjoyed this video and hopefully learned something, drop a like and maybe subscribe for more plumbing videos. And be sure to check out the how-tos here for more professional advice. See you on the next one.